So some of the other things that are in place, not only is it access and control type issues or group policies that prevent us from accessing things, but it's also the regular end users safety. So you leave your phone on the table, you forget about it, you can have a password on it or the biometrics just to lock the phone for simple use, so that only the end users going to use it. Because of all these different features that are securing the device, we have to find a way around those security features so that we can obtain the actual physical extraction if possible. Or in some cases, we're not able to get to the physical level and we can only get a logical extraction. So part of the process is understanding that there are many partitions on a phone. A lot of times we think of the partitions of, hey, we have the recovery partition. Now, the recovery partition is something that that if your phone gets messed up, you can hit a key combination and have the phone start up into the recovery area, which circumvents or rather, when you start up a device, it is set to go straight into the system partition in a normal user type environment. If you select a key combination on the phone, it will kick you either into a bootloader mode or into a recovery mode. When the device gets into a recovery mode, the reason for the recovery mode is to either update the operating system. Maybe the main system got a virus or had some sort of issue with it and you need to refresh that system. Maybe you want to wipe the device so that you can resell it and send it on its way and be ensured that your specific information is not getting sent off to whoever it is you're sending to the phone or pawning it or however you deal with it. So when a phone initially starts up, we have on computers, we have our BIOS boot sequence. So you hit the power switch, the electricity goes into the different circuits. It checks its peripherals to make sure that, hey, the screen's working, the keyboard's attached. And if something kind of goes wrong, you get kind of some beeps that if the physical components aren't quite there, the motherboard will beep at you. And then in that boot process, if all the peripherals are good, it then hands off the boot process to the hard drive, and it starts a chain process where it loads the first file on the drive, which then builds up enough software on the backside to understand the next file that it loads in. And as it chains these different files together, eventually you come up with a main operating system. In that process of booting the device, file systems are mounted, different software or processes are run in the background, such as encryption. When a lot of times in forensics, the analogy of a hard drive being a library where the file system, you can look in the card catalog and it will list the actual files. And then once you find the file in the card catalog system, you can go to the bookshelf where it's actually located and pull that book off the shelf. Well, in that boot process, the librarian comes into play, and the librarian now tells you you have access to certain parts of the system or you don't have rights to a certain part of the system. So in that boot process, we're kind of putting all this structure together that puts the rules and access and control system or security measures into place. We already talked about this, the BIOS of the computer. In an Android operating system, that the bootloader, when it starts up, it loads the system kernel, which are the essentially the drivers that are needed to talk to the hardware. And again, it populates itself and getting the different services ready to go. And in that, there are different security checkpoints that can cause us issues when trying to access the phone. A lot of times we'll put the phone in the Android debug mode. We'll try and issue Adb commands. When we go into that process, everything that is started up, if we can break that boot chain, then we can overcome some of the security measures that are put into place. So it's the bootloader is the first program that's run, and it's specific to the hardware in the device. So when the electricity is applied, this first bit of information would say, hey, the different partitions where the data is contained, we need to go to each different partition, and of course every phone's going to have a different layout, and those partitions are going to start at a different location. The boot loader is the one that knows how to deal with each of these partitions and files that need to be chained together. We've already talked about the different carriers and the original equipment manufacturers. Part of that boot process is there can be check values in the boot chain. So the bootloader starts up and it knows that, hey, the next file in the sequence of files we want to load up, it has a specific hash value, and we're going to check to see if that hash value matches what we have stored, and if it doesn't match, then we're not going to let that boot process occur. So that's one of the obstacles that we have to overcome. When we're firing these things up and we want to get the Android debug bridge running so that we can actually communicate with the device, this image kind of gives us a display of the process of it starting. So right straight down the center, we have the device powered on, the bootloader fires off, it then starts loading the kernel, it starts the initiation process, fires off some zygotes and those different processes that need to be running, and eventually we get into normal user mode, which is down here center. Now, by pressing key combinations on the device, we can force the device to go into either recovery mode or into Fastboot mode. So recovery mode is essentially a pared down version of the normal operating system with limited functionality to it. The bootloader mode is essentially the Fastboot or bootloader mode is a location where we can essentially overwrite different aspects of the partition, or we may be able to overwrite the bootloader itself. So in a lot of these devices, you're going to do your volume down, your home key, and your power button for a set amount of time, and it's going to start the device into the bootloader aspect. Part of putting it in that bootloader or Fastboot mode is that different communication protocols are started up. So you may have access to or be able to communicate with the device via Odin, or you may use Fastboot. Each different make and model and manufacturer kind of dictates on what communication protocol is used, and they are the ones that decide how that goes. So if we were to go into the bootloader mode and we decided we wanted to load a custom recovery onto the device, we would go into that bootloader mode. We'd actually replace the recovery partition with a custom operating system. And in doing so, we would gain the root privileges that we'd need, and it would open up the Android debug protocols that we would use to access the different areas. We'd have to identify the user's data. We use BusyBox along with the DD command to extract the user data from there. And part of it's understanding at what point is the or in what version of Android is the user data encrypted. Can we just pull a specific partition, or do we have to look for a encrypted or decrypted version of the file system on the computer or on the phone? So we kind of already talked about Fastboot, and Fastboot's just an executable file that you have on your computer, and it's a communication protocol that exists on the device for the right manufacturer. Samsung uses Odin to communicate back and forth. Odin and Fastboot are similar in that they're used to replace different partitions on the phone. So again, I kind of already glazed over this. Recovery mode is a runtime environment. It's where you're able to do, gosh, I'm fumbling on my words here. You're able to factory reset your device and do updates via SD cards and such. So we get into each one of these ones. Again, I've touched on this by pressing a key combination, a volume down, home, and the power button on the Samsung devices. LGs are something like hold volume down and then plug in the USB, micro USB cable. There's a bunch of different ways, and we go into each of those processes for each of the different mobile devices. There's a handful of mobile devices in the class that we will physically go through the process of flashing and extracting the data out and putting it in these different modes. Part of going into each different phone is each phone has different drivers. There's different characteristics of, does that driver automatically instantly start talking with your phone, or are you getting a brief glimpse of the driver appearing and then it goes away? And so these devices can be very finicky, and unlike some of the major cell phone forensic softwares that exist out there, when something doesn't work, you have to kind of understand what's going on the backside of it. And if it's a driver issue, how do you identify if it's a driver issue or if it's a software, or do I have a bad cable? One of the major tools that I use frequently, if I'm having problems getting a phone to actually connect and talk to the software, I shut the entire program down and I do the same steps that the software would suggest to me, but I have my device manager open, and you can see, you know, is EDL actually firing off? Is the computer recognizing it as EDL? Because when the actual software is, the forensic software is running, it's capturing your devices in the device manager, and you're not seeing the normal behavior you would see of the phone and what's going on. So in this bootloader course, we're showing you how things look not using the major forensic software. What are the fundamentals of extracting data? So a lot of this I've already talked to, so I'm just gonna pop through a few slides. Some of the different partitions that exist, and again, we see these when we put a device into recovery mode. We'll see that there's a system partition. We'll see that there's a cache partition. There's a user data partition. The system partition holds up your normal boot process. When it starts up and you get your user screen, you'll see that just the normal general starting of the device. The cache partition is kind of a place that the device can store some peripheral information, some temporary data. And some of the things like, hey, I just did a system update, and I'm going to get a new version of the operating system. Well, it has to store the information it's going to replace what you're currently running. And so the cache will have some of the flags of, hey, when this reboots, we need to load new information on. typically when we're dealing with the cache partition, if you were to wipe that cache partition, there's not no direct end user data is stored on the cache partition. I've talked to different people, and some people have told me, hey, there might be some Wi-Fi connections or some log information that may be of some investigative value. I myself have not dug so deep into that area to actually need to use that data. The partition that we're mainly concerned with is the user data partition. This is where all the end user information stored, all the pictures, all the call logs, all of the investigative value. If we wipe the user data partition, the phone is essentially put back at factory default. And that's ultimately what we're trying to avoid. So in the process of flashing specific software onto the device, it may have packaged in with it, because all these, if we go to the original equipment manufacturer and we download their package of original firmware, and we dig through that package, we'll start to see that they actually have a slot for the user data in there. And if we were to flash that original equipment firmware on there, it's going to overwrite the current partition with the end user's data. So I wanted to show how many partitions actually, or what sorry, as I try and do two things here at once, try and show what the actual partition layout looks like. So we're used to seeing the what's on the recovery partition, just the user data cache and system partition, but there's actually quite a bit more. And I don't know if a lot of you have actually dug around and played with the devices, but getting into the Android debug mode, you can start to poke around and see, what file systems are mounted, how are they mounted, where are they mounted, what are their sizes, and try and get an understanding of the layout of it. So what I've done here is I have my personal phone on the right-hand side, and we swipe down from the top. I hit the sprocket in the upper right-hand corner, which takes us to our menu. We go into the About Phone settings to turn on the Android debug bridge. We have to go into software, and then we tap on the build 7 times. And most of you who've done forensics, you've done this 100 times. My phone's now asking me for my swipe pattern to unlock the developer mode. Once we hit 8 times, we get the developer options down at the bottom. We'll select that. We'll tell it to, hey, stay awake, and turn on USB debugging, and we'll hit OK. You can hear that the communication protocol had just turned on. You can hear that the device is connected to it. And if we run the Adb command and we ask for devices, it will show us, hey, there's a device connected. This is the serial number of the device. And because I'm actually getting the device instead of unauthorized, if we were to get unauthorized, unauthorized would indicate that we have to agree with the communications between the phone and the computer. And typically it gives you a pop-up window on the phone to accept. So real quickly, I just wanted to show, I got some pre-typed up commands here so that we can kind of breeze through this. So one of the commands we look at is cat proc partition. So the way this is working, I'm calling the Android debug bridge. I'm saying, hey, in the shell, I want you to execute cat, which is basically read to me what exists in the file. And then the file we're looking at is in the directory proc partitions. And then I'm kicking that information out into a partition size text. And so I'm going to hit that. Okay, so there goes our partitions. I'm going to kick that out into a text file so that we can put that over to the side. And then I am going to execute this other command here. So what this next command is saying, hey, we're calling the Android debug bridge protocol. We're getting into the shell. We want to list, we want a long list, and we want to make sure that we're getting system protected files. That's what the DashLa stands for. And we're going to go to this dev block platform path that is going to list out the different partitions by their actual names. Now, each device, this isn't the same path every time. You'd go under dev block platform. You should have an SOC, and then the following name, the 6240, I've seen on different devices that it changes each time or can change each time. But typically, as you delve down this path up under platform, you should eventually find a by name, and that will list out those files or the partitions that we're looking for. So we're going to open that. And try and separate these out here. There we go. So here we can see that in the typical Unix type environment, we have the storage device A, and then 1, 2, 3, 4, 5, and so on. But it tells you the size of it, but it doesn't tell you what it actually is. When we do the command of list the different partitions, here we can actually, on the left-hand side, we can see what the names of each one of these partitions is. So we can see that, hey, SSD 10 is the A boot. Where's the other one? FRP. FRP is SDA 11. We have persistent data. Here goes the recovery partition is actually located at SDA 18. And we can see by looking on the right side that SDA 18 is relatively small. This is all in bytes, so it's only 77 kilobytes in size. One of the interesting things looking on the right side is we can look at the size of these different partitions. And we see that SDA 23 is one of the largest partitions that exists on there. And that's kind of our hint as to being the end user data, because typically you'll see that the end user data is going to be the largest partition or section on the actual hard drive. And we can see here that the user data is also named off as user data, and we see SDA 23. So we actually put a name with it. The tricky thing about this is that the user data is, if we were to pull this, once we obtain permissions and we pull this SDA 23, this is all going to be encrypted, and you're not going to be able to make sense of it. Because when the system starts up, it mounts this SDA 23 as a file system and decrypts it. And so the decrypted version of the same thing is down here. And we can actually see that the size of it is exactly 16 bytes less than SDA 23. So when we actually get in and we get the root permissions, we're doing our DD command, and we're trying to pull out the DM1 partition, which is how we'd identify the user's data at that point. So I'm looking at the time. I think I've probably gone a little bit longer than I should have. This was an attempt to give you a taste of what the class is. It goes a lot more in depth. We look at a lot of different phones. We show you how to deal with encryption, not only on the Samsung, but some of the HTCs and other stuff going on. A lot of this is understanding the fundamentals of how data is extracted. You have your major forensic tools. They give you a lot of push button. They make everything push button easy, which is why we pay them the big money to do that. But when things go sideways or they don't actually support the device that you're interested in, there are methods to go about and identifying how to get the data out, how to get those root privileges. And one of the things that you're going to have troubles finding in any forensic class is that extraction portion, because you're borderlining on this hacker/forensics. We have to use an exploit and we have to change something to get in the device and actually get the information. So what does that process look like? How do you start from the basics and build yourself up to the complex, where now we have bootloader handshakes and everything else going on? If you are out in the wild and you're looking on the internet for any type of solution to get into a phone, how do you identify those phones? How do you test and validate that the exploit you're looking at is something that has forensic capabilities? If you have a Chinese offshoot make of a specific phone, how do you identify what hardware exists in there? How do you then maybe find another device that has similar hardware in it and use your commercial forensic tools and try different makes and models to see if you can't effect an extraction under a different model because the underlying hardware is the same. So this has been kind of an attempt or a teaser to get you guys to learn more, and we can dig into all the way down into the weeds, or we could do a 20,000 foot flyby depending on where your level's at, and there's lots to learn. So with that said, I think I'm going to hand it over to Ken and see if we got any questions or, yeah.
Yeah, thanks, Tyson. So far, no questions. Yeah, anyone who wants to ask a question, go ahead and put it in the group chat, and then me and Tyson will get to it. I just wanted to reiterate that we're going to be sending out a recording of this session. I'll be sending it to your email that you used to register for this session. So I'll get it to you sometime this afternoon. Okay, so still no questions so far. So let's just like hang out for a little bit, see if anyone pops in.
Can I provide the commands again? Sure. So the commands, one's just ls, which is, list in the Unix environments. It's same as dir. It lists what working directory you're in. And again, the path to the by name will change slightly from different models, and it may not exist in every model of phone. It all depends on the manufacturer, the cell phone provider, as to whether or not they want that accessible to the end user. But the proc partitions, that's pretty consistent across the Android devices. Also, if you're not familiar with the command line, these carets indicate take whatever the output of the previous command and put it into a text file. And this is the text file that just the naming convention I decided to use. Any other questions?
Yeah, why don't we just give it another 30 seconds. Yeah, once again, we're going to try to have these. First of all, I apologize for the dog in my background. But yeah, we're going to have these sessions about once a month. And so I'll be sending out an email to you. Promise not to send out any other extraneous emails unless you're signed on to the main Teal Tech mailing list. But yeah, we'll be having these next month. I don't have a date yet so far, but I will get in touch. And it seems like we don't have any more questions. So yeah, I would like to thank you, everyone. Thank you, Tyson. Thank you for providing all the information that you did. It's very in-depth analysis. I really appreciate that. And yeah, thank you, everyone. And hope you have a good weekend. Thank you.